All right. So my name is Anto Joseph. I work for this protocol, EigenLayer. I work at EigenLabs, the creator of EigenLayer, the protocol. I am a security researcher there. So what is EigenLayer? EigenLayer is a protocol built on Ethereum that introduced the concept of restaking. So we have since gone past just restaking, and what we do currently is shared security. So you can provide security and bootstrap networks built on this shared security. We call it programmable trust, and I will dive into what that is. One of the core problems EigenLayer is solving is bootstrapping decentralized infrastructure. So if you're a new L1, you know that it's really hard for you to get stakers, operators, and get them all to run your software, right? So this problem has been solved by EigenLayer. So before we dive into restaking, we should understand what is staking, Ethereum staking, right? So a very high level of what Ethereum staking is, it looks something like this. You deposit 32 ETH into a deposit contract, it's pending for a while, and you run your validator, it verifies the blocks, and then your ETH becomes active on the beacon chain. If you follow all the rules, you get rewards for it. If you break any rules, you get slashed for it. So what is restaking? Restaking allows stakers who have already staked on the beacon chain to use that same ETH that is available on the beacon chain to secure additional networks. So how can we do that, right? We want you to set the withdrawal credential of your validator to a smart contract. And we have the smart contract called the EigenPod, which, so as a validator, you would set your validator's withdrawal credential to the smart contract. So we are able to slash for any actions that you may have carried out while you were validating any of these additional networks. So for example, if you are a bridge and you made a commitment to do a certain task, but you didn't, then when you withdraw from the beacon chain, your ETH would end up on the smart contract, and then we can slash for that particular amount, and then you will be able to withdraw the rest. So that is how restaking works. It is also capital efficient, right? When you bootstrap net new networks, you are splitting up capital. So if you want to run your own L1, you have to have a certain amount of economic security backing it. But when you talk about the concept of shared security, with EigenLayer, you are sharing all that economic security among your AVSs. I'll dive into what those are. But you can see that it is a much better system, pooled security versus monolithic. So these are the 4 components of an EigenLayer marketplace. We have the consumers, which could be the roll-up users. We have the stakers who deposit funds to us, so that's really what economic security is. And we have the AVS developers, so something like a prover network, you could call that an AVS. And operators who runs these AVS, so something like Coinbase Cloud. So we have experienced good TVL growth. And these are some of the operators with different capabilities that are currently on EigenLayer. So if you have a proven network, you can pick the operators with GPUs. If you are running a TE network, you can pick the operators with those capabilities. And yeah, this category just keeps growing, right? This is just a screen cap of what we have right now. And we have about 18 of those on mainnet, 40 on testnet, and 100 plus in development right now. So a very high-level overview of what the protocol is before we dive into the exciting bits, which is slashing, which is a pre-release on DevNet right now. And we are very excited to share that architecture with y'all. So 30,000-foot overview. Stakers deposit their tokens onto a smart contract. Stakers delegate that capital to operators who would run this software, the off-chain software. So just like how Rocket Pool or Lido would work, you delegate your capital to an operator, and the operator runs the validator for you. So just like that, the staker delegates the capital to an operator, and operator runs the software. Now, there is a slashing contract. So what is a slashing contract, right? Imagine you are a bridge, and a bridge validator has to follow certain rules. So a slashing contract enforces those rules. So you can think of it as how Ethereum works, right? Ethereum has certain rules, like do not double sign a block. That is a rule that is enforced by the Ethereum clients. If you do, you get slashed. So just like that, you can write smart contracts that is a slashing smart contract which verifies if you have committed a fault or not. If these faults are cryptographically verifiable, then it is easy to write a smart contract. And you can use fraud proofs, you can use CK proofs, you can use many mechanisms, like even a Merkle proof to prove something. So it's completely up to the AVS how they design it, but we obviously want the slashing contract to be really secure. So please get all your audits when you write something like that. Okay, so we talk about programmable trust, right? So what is programmable trust? The amount staked, we call it economic trust. The geographic diversity, we call it the decentralized trust. And a lot of Ethereum validators also opt into running these AVSs. So they can make commitments like, when I get to propose my next block, I will include this specific transaction. And you can verify that on-chain. So that is the Ethereum trust. So what can you do with programmable trust, right? You can build apps with commitments. So what are apps with commitments? The OG Bitcoin, there is a commitment. Only 21 million Bitcoins ever, right? And what is a commitment from Uniswap? Find the fair market price. And what is it from Aave? The lenders, assures the lenders that borrowers were never under-collateralized. So we have Uniswap, Bitcoin, Aave, Polymarket, all of that today. And these are the technologies that underpin the services. But can we create an Uber competitor that makes a commitment like, I will never take more than 5% take rate? Can we do that today with what we have? This is really where apps with commitments can make a difference. So we have this analogy. We call ourselves the verifiable commitment cloud, and you can see why we are doing it. So at the staker, operator, and developer level, you can make certain commitments like we will not censor, we will not double sign. And these are at that AVS level, and then you can have app level commitments depending on the app that you're trying to build, right? So if you're Uniswap, I make an app level commitment to make sure I always have fair ordering and finality. And so you can see how it applies for Aave and Polymarket, right? Now, to have apps with commitments, you need a carrot and a stick. The carrot is the rewards. The stick is slashing. So we have rewards on mainnet already. So I will not be going into that. But what we don't have right now is slashing. So I'm really, really excited to say that we have slashing pre-release on DevNet today. So if you scan the QR code, you can find the GitHub repository, which is a pre-release. Things are going to change, but if you are excited, this is pre-audit. Things are going to change, but we are excited to put it out there. Play with it. And slashing is a two-part release. So the first one that we have on the DevNet is where the malicious operator's delegated stake is slashed and burnt. So the stake is burnt. And the V2, the malicious operator's delegated stake is slashed and sent to the harmed parties. So you can think of it as insurance. So we have a term here called StakeSure. That is the white paper that we put out, which talks about the insurance model on EigenLayer. So if you're interested, just Google that, and you'll find a nice white paper out there. So some key concepts with slashing. We introduced this term called operator sets. So operator sets is a grouping of operators who have been delegated ETH. So when I say ETH, it could be like any token because we accept any arbitrary ERC20s now. So when you see ETH, it could be like anything else. So who have been delegated these tokens by the stakers and are assigned certain tasks by AVS. So what are tasks, right? So imagine you are a prover network and you want to generate a ZK proof. So you can assume that it is a task, and this is a task that an AVS have to respond to. So operators run these AVSs, and the task is to generate a ZK proof for this data that is provided to you. So tasks are dispersed to these operator sets, and we have this concept called total stake. The total amount of ETH delegated to an operator is the total stake of that operator. And an operator set's total stake is the sum of all the operators' total stakes. So as a staker, I might choose to delegate to a solo operator, like solo staker, right? But you may choose to delegate it to the operator that is run by Coinbase or something. So the total stake that is delegated to an operator, right? That is really what we are talking about here. And unique stake. This is what is very different from our previous slashing model. Operators allocate a percentage of their ETH or any token that an operator set is permitted to slash. So this unit of ETH can only be slashed by a single operator set at any given time. So you can be assured that multiple parties do not have claim to the same ETH. So you have unique rights to slash a certain amount of ETH. So that is a guarantee that the protocol gives you with this new slashing model. And we call that unique stake. So this is what operator sets look like. You can see a staker has 300 ETH, and they have delegated 100 ETH each to 3 operators, and they all run AVS1. And you can see that AVS1 has multiple operator sets, and operator 1 only has the operator set 1. Operator 2 and operator 3 is opted into both the operator set 1 and operator set 2. And you can see that some tasks are only allocated to operator set 1, and you can see certain tasks are only allocated to operator set 2. So B and C, task B and C is allocated only to operator set 2. So this is a nice way of AVSs can have multiple operator sets, with varying levels of total stake and unique stake. So it is very versatile, and you can use it depending on the task at hand. So total stake, right? So this is an operator 1 with the 100 ETH staked. So this is an example operator allocation of unique stake. An operator can allocate less than 100% of their stake. You can see that the operator allocates like 50% of their stake to AVS 4 on operator set 5, and AVS 3 gets 30% of their ETH, which is operator set 4, and operator set 3 gets 5%, and operator set 1 gets 0. So what that means is that an operator can run multiple AVSs, and out of all the stake that is delegated to an operator, they can choose to split the percent allocated to the operator sets, and that stake is uniquely attributable to that operator set. And as you can see here, this is how unique stake works. A unique stake is the amount of stake that is uniquely slashable by an operator set. So this is a combination of the previous slide and the slide after. You can see that AVSs have multiple operator sets, and there is unique stake allocated to operator sets. And you can use a combination of total stake and unique stake because they have different properties, right? Total stake is just like the sum. Like you can see that the total stake is a total amount of ETH delegated to an operator. And the unique stake is the amount of stake that you have unique rights to slash. So if you wanted to, for your AVS, you can choose a rule like I need 50% consensus on both total stake and unique stake. So these things have good properties. So total stake raises the amount that is required to attack your AVS, and unique stake also burns attackers' funds because that stake is uniquely attributable and slashable by an operator set. So by making a decision to like maybe have a 50% consensus on total stake and unique stake, you raise the bar for attack and you increase the damage to the attacker. So you can read a lot more about the slashing model in this blog post. So you can just scan the QR code if you are interested. So this is our new and improved slashing model. I know someone was trying to scan the QR code. Sorry about that. Got it. OK, so this is the new and improved slashing model. What is good here, right? The greater control over slashing risk, and you have guaranteed slashable stake. There is no more a need for a common veto committee, and you have permissionless onboarding of AVSs. And what are the risks and mitigations, right? So we have crypto economic attacks, AVSs with not enough security budget. Imagine your security provider pausing for an upgrade. What happens to the security of an AVS, right? So these are interesting things to talk about. We have this concept of an allocation delay within the protocol. This allows stakers to react before the stake becomes slashable in a new AVS, and this protects against malicious operators. We also have a deallocation delay, which prevents withdrawing stake immediately after malicious actions. So the stake remains slashable during this window. And it is one of the most important things. The cost of crime should be bigger, right? So if you do not have crypto economic safety, you will get attacked. And we will have insurance in the next upgrade. So it's fun to think about all the things that can go wrong when you have heard of insurance fraud in the real world, right? So this protocol becomes a lot more complex and interesting once you have insurance. And we cannot forget about Web 2 security. So we have docs. If you are an AVS developer, if you are an operator, please follow these best practices. And that's pretty much it. I have a lot more slides, but we are out of time. I'll be over there, so if you have any questions, I'll be taking those. And thank you so much.